Okay, guys, so let's let mu equal the true average lifetime for a certain type of pen under controlled laboratory conditions. All right, so our null is that mu is equal to 10, and our alternate is that mu is less than 10. So mu is equal to 10. And if we take a random sample of 36 pens, find beta and power of the test if the true mean is indeed 9.8 with a standard deviation of 0.6 and alpha equaling 0.10. All right, so here we are on a number line. We're doing a lower tail test. We've got a distribution centered at 9.8 and one centered at 10. We have the null centered at 10 with an alpha of 0.10. So here we go, 10. I'm gonna estimate that alpha is somewhere over here in that lower tail. And here is the other curve that we need to draw. Remember, we're just stealing this alpha value so that we can approximate beta. We are stealing that critical value to approximate beta. Beta and alpha don't necessarily overlap, so we can tell which direction is which because we shade the opposite. So now I want to find out what is this value because I'm trying to get to my power, which is over here. So let's find out that value using z-scores. It's gonna be z equals x minus mu over sigma over root n. And I know that that alpha over here is 10%, so I can use inverse norm to find out what that value is. 0.100 0 and 1 gives me a critical value of negative 1.282. So I've got negative 1.282 equals x minus. Now remember, we are using the null hypothesis. So we're using a mu of 10 in this case over the square root of sigma, which is 0.6, divided by the square root of n, which is 36. We can crunch that out, and x is actually 9.8718. So we actually, in this picture, kind of underestimated where that alpha value lies. So we can actually adjust the picture if we want to. I'm gonna pause and do that for you. All right, so now I went ahead and fixed it because our critical value is actually above this point. It's up here. 9.8718. All right, so now I want to find beta using the critical value and the alternate. So we've used the null hypothesis curve to find this boundary line, and that's all we used it for, is because alpha and beta share a boundary line. So once we get this boundary line, we are done with this curve because we don't think it's true. We are assuming the alternate is true. So beta is the area above 9.8718. So we're looking at the probability of an x value greater than 9.8718. And this is when mu is equal to 9.8 because we are solely looking at that red alternate hypothesis curve. We can use normal CDF now. A lower bound of 9.8718, an upper bound of something big like 1,000 or 10,000, whatever. Your mean or your central value is 9.8, and your standard deviation is 0.6 over square root of 36. We can crunch this out, and we get out a value of 0.236. So we have a 23.6% chance of making a type 2 error. And to find power, we take 1 minus 0.236, and we get 0.764. So there is a 76.4% chance of making a correct decision. And of course, remember that correct decision is we favor the alternate when we should. All right, let's move on to the next one. Optical fibers are used in telecommunications to transmit light. Current technology allows the production of fibers that transmit light about 50 kilometers. Researchers are trying to develop a new type of glass giver that will increase its distance. Mu is the true average transmission distance for a new optical fiber. Okay, so my original claim is that mu is equal to 50. My alternate is that mu is greater than 50. If we take a random sample of 10, find beta and power of the test if the true mean is 52, which favors the alternate, saying that it's greater than 50, standard deviation of 10, and alpha is equal to 0.05. So we're doing an upper tailed test here. So I've got something centered at 50. Remember, this is just a number line. I've got the null hypothesis centered at 50. And I've got an alpha value of 0.05. It's in the upper tail. I'm going to estimate it's up here. And I've got the alternate curve centered at 52. All right, I want to find this critical value. It might not be drawn to scale, so let's find it. Z equals x minus mu over sigma over root n. This area up here, this alpha is 0.05, so I'm going to find that z value. Inverse norm, the area to the left is 0.95, 0 and 1. That would be 1.65. Yeah, 1.65. Okay, so let's plug everything in. 1.645 equals x. We don't know that. That's what we're looking for. Minus mu. This is on our blue null curve, remember. We're using this information to find that critical value, and then we're done with it. Equals x bar minus 50 all over 10 divided by the square root of 10. And we get out x is equal to 55.202. So this is not perfectly to scale, but it definitely is above 52. 55 is, somewhere over here. So we've got this area expanding to 55. Okay, we're going to erase this. Okay. Now what we're saying is we're going to use this critical value to show me beta and power. So here is beta, and according to my drawing, the power of my test is over here in the tail. Okay, I want to find out what that critical value is, 55.202. I want to find that probability of beta. Beta is that red area. It's the probability of an observation less than 55.202. But remember, this time we're dealing with the alternate. We use the null to get that critical value, and we don't even think it's true, so we're only looking at the alternate curve. So we're going to use a mu value of 52. So the this is normal CDF, 55.202. something big, 10,000. The mean is 52, and standard deviation is 10 over root 10. And we get out approximately 0.844. So there is an 84.4% chance of type 2 error. 1 minus 0.844 is 0.156. There's a 15.6% chance of making a correct decision, of choosing the alternate when it's true. Okay. Use the information above if mu is 70. All right, so we start off with a null of 50. Let's see what happens. So we start off with a null centered at 50 still. This is not the best picture of my life. And then I've got a null centered at 70. And I'm actually going to make this better. And I know alpha is somewhere in this upper tail. So let's see where it's located. I know that the alpha value is 10%, or it's actually 5%, sorry, 0.05. So inverse norm again, 0.950 and 1, and I get 1.645. So 1.645 equals x minus mu is 50, because we're dealing with that blue curve, right? We're using the null curve, over 10 divided by the square root of 10. And you should get that x equals 55.202. Same situation as before. So here we are at 55.202. And here's alpha. All right. So then the opposite down here, we've got beta. And here, oops, I didn't mean to erase that. And here is our power. All right, for this next one, remember we're only looking at the alternate curve. I want to find the probability of beta, and beta is the probability of being less than that 55.202. So the probability of an x value less than 55.202, we're using mu equaling 70 now because we're on the red curve. And we're going to use normal CDF of negative 1,000 or something big, 55.202, mean is 70, standard deviation 10 over root 10, and you should get out approximately 0. So there is an approximately 0 of a type 2 error. So there's approximately a 100% chance of making a correct decision. All right, 2 more. Let the true mean weight of starting football players be equal to 105 or less than 105. So the null is that it's equal to 105. The alpha value is 0.05. The alternate, that indeed it's actually less. And we find out to see this actually 103.3. So let's draw our curve, one at 103.3, one at 105. That null curve is at 105. And the alternate curve is at 103. Since this is a lower tailed test, I know alpha is somewhere over here in the lower tail. I'm going to find out what that is by using the inverse norm. 0.05, 0, and 1. We'll get negative 1.645. Negative 1.645 is equal to x bar minus mu. Remember, we're on the null curve right now to find that critical value. So mu is 105 over our standard deviation is oh, I forgot to write it in for you guys. Sigma is 1.5, so you guys could have done this problem without this. 1.5 over the square root of 33. And you'll get out that x is equal to 104.57. This was just missing. Sorry. So 104.57 is somewhere like here. So that represents our alpha value. We use that critical value for beta. Here's our beta on the red curve. And our power on the alternate. So remember, for this one, we're using the alternate curve because we're assuming it's true, and now we use the null to give us that critical value. Now we're not going to use it again. So in order to find beta, I'm looking at the probability of an x value being greater than that 104.57 when mu is equal to 103.3, because I'm on the red curve. Normal CDF, lower bound 104.57, upper bound something big like 10,000, 1,000. Mean 103.3, standard deviation 1.5 over square root of 33. And you should get out approximately 0. So there is an approximately 0% chance of a type 2 error. Approximately a 100% chance of making a correct decision. All right, last one. A candy store, the owner uses a scale to fill bags with 2 pounds of candy with standard deviation of 0.05 pounds. The null is that the mu is equal to 2. The alternate is that it's actually less, or actually greater. And we took a sample to find it to be 2.2 pounds with alpha equaling 0.05. All right, here is our number line. We've got 2 and 2.2. We got the null hypothesis centered at 2. And the alternate centered at 2.2. Ew. This is an upper tailed test, so I know alpha is somewhere up here in this upper tail. I'm going to find out what that value is. Since it's 0.05, we're using inverse norm. The full area to the left is 0.95. Mean is 0, standard deviation is 1. And of course, this is 1.645. So 1.645 equals x minus mu. we're dealing with that blue curve for this problem, and that mean is 2 over standard deviation 0.05 over the square root of 100. So you get x equals 2.008. So on the scale, 2.008, it's probably somewhere like right here. So there's alpha. All right. On the opposite, on the red alternate hypothesis curve, here's beta. And then here's your power. Finding that probability of beta is the probability of an x value being less than that 2.008 when mu equals 2.2, because now we're using the alternate curve. We never believed the null was true in the first place. This is a normal CDF. A lower bound of something big like -1000, upper bound 2008, mean 2.2, standard deviation 0.05 over square root of 100. The p-value here is approximately 0. You have an approximately 0% chance of a type 2 error. So approximately a 100% chance of a correct decision. Okay, guys, so make sure you get down how to draw these curves. Make sure you understand these are two separate curves. In this step, we're using the null. In this step, we're using the alternate. And power is just 1 minus beta. So it takes a little time. It takes a little bit of practice. If you need help, office hours is dedicated to stats only on Wednesday from 12 to 1. So I'll see you there.